We know that bats fly. They see with their ears. And sometimes they even fight crime. But did you know that their DNA holds secrets that could revolutionize medicine? Bats have long lifespans. They resist cancer, and they shrug off viral infections. So today, I'm here to talk to you about how we can learn from bat immune systems to help inspire groundbreaking therapeutics. When we get an infection, we react with an inflammatory response, a bit like an internal alarm signal to activate the immune system. But in bats, this internal alarm is dialed all the way down. They like it nice and quiet. And as a result, bats tolerate viral infections much better than we do. They catch infections, but they don't get sick. One of the reasons we get so sick is because of something called the cytokine storm. So a bit like the superhero Storm from the X-Men, we all have the ability to brew up a storm of inflammatory signaling molecules known as cytokines, with funny names like interferon gamma, interferon, and interleukin. And unfortunately, like Storm, we sometimes lose control of our powers and wreak havoc on the world around us. This, in our case, is tissue damage, and it can lead to severe and sometimes even lethal cases of infections, as we see in COVID-19. Now, I've spent the last 3 years figuring out how bats are able to avoid this kind of problem. And to do this, I sequenced the DNA of multiple bats. And in the end, I analyzed a rich roost of genetic information, looking at everything from the little brown bat eyeing that tasty moth morsel there, to the vampire bat that's ready to swoop down on you guys for a little tasty blood meal. Now, combining all of this genetic information and comparing it to mammals, including ourselves, I was able to make a striking discovery that's been accepted for publication, finally, earlier this month. And I found something interesting on chromosome 19, specifically on the small arm of our chromosome 19. And on the left-hand side, what I'm showing here is a comparison between humans and mice at the top and bats below in this genetic region. And what I'm showing here, like pearls on a string, are the different genes that we have, and the different colors denote different flavors of this gene. So in silver, because it's worth less, the interferon alpha cytokine, which we tend to have a lot of. And in gold, which I prefer, the interferon omega, which, as you can see by eye, bats have a whole lot of. And if you don't trust your eyes, well, trust the statistics. This is a statistical bat test comparing non-bats to bats, and we can see non-bats have a lot of this interferon alpha, fewer omega, and in bats, the situation is flipped on its head. Bats like things upside down, don't they? Now, why do we care about this at all? Well, as you can see from these beautiful 3D protein models, interferon alpha and omega look pretty damn similar. But I've highlighted in red the molecular differences between the two, and you can see there's quite a few of them. So why are these molecular differences relevant? Well, they confer a unique ability to interferon omega, which bats like. Interferon alpha and omega both act a bit like the bat signal. They send a signal to a localized area saying that there's villains, like viruses, about, and by doing that, they recruit macrophages, B cells, T cells, to come knock them out. But interferon omega is different from interferon alpha because it helps mount a stronger and more potent antiviral response. And it's this that I believe allows bats to avoid the runaway immune response that we have by nipping viral infections in the bud very early on. So to close, I want to come back to Batman and why he's my favorite superhero. And it's not just because I wouldn't mind being a billionaire. Batman has no superpowers, but his special ability is to always have the right tool at the right time. And for bats, that right tool is interferon omega. Now, we can harness this same tool as a therapeutic, which interferons are viable as, conferring on ourselves similar viral tolerances. There's big money flowing into this, and I believe that with work on bat longevity and bat cancer resistance underway, that when we combine this with the immune findings that I have, that over the coming decades, we will all truly see bat biotechnology take flight.